Okay, so we've been talking about these construction-based shapes and finding their areas. The one we're going to look at, start with today, I should say, is a gambrel style roof. And gambrel style roof, as you all know, is just kind of the barn style roof or woodshed style roof, however you want to call it. Where you have, it's called a pitch break or a change in slope partway up the roof. Let's say we've got a 16-12 slope down here. And up here, we're going to go with a 512 slope. Let's see, we'll find our overall height. Actually, we'll go ahead and give you an overall height here of 13 feet. And let's go with a slope here of 36 feet. Sorry, a span of 36 feet. Okay, so we have those dimensions. But let's look at what it is I'm going to be asking you to find. What am I expecting to calculate from all this? Oh, let me get my mouse out of the way. What I want to find, if I put a attic room inside the truss for this, I am going to want to find, I'm going to call that dimension W from the end of the span to that inner wall. I'm going to call this dimension here across the room dimension Z. I'm going to call my wall height Y. And I'm going to call the height up here X. So I want to find those dimensions and I want to find the area of this. The area is going to be pretty easy when we're done. It's going to be three triangles and a rectangle once we have all these dimensions filled in. The other things I'm going to ask you to find, I'm going to find this angle. I'm going to call that angle theta. This angle up here, I'm going to call angle alpha. And this angle here, I'm going to call angle beta. And up here, I'm going to call that one angle phi. And just using Greek letters instead of our Arabic letters and stuff for the variables for the angles. Okay, so let's get started on this. The easy part is going to be to find the angles. I'm going to start by finding angle theta because angle theta simply comes off of that 16-12 slope. So we've got a rise of 16 and a run of 12. Theta is just this angle here. Well, according to that theta angle, 16 would be the opposite side and 12 would be the adjacent side. That's a tangent. So to find the angle, we're looking at an inverse tangent of the opposite side, which is 16, over the adjacent side, which is 12. Make sure my modes are set, and they are. Got 53.13 degrees. Now with that, alpha is easy to find because this has to be a right angle here because that's a vertical going into a horizontal. So alpha is just the complement of theta because those three angles have to add up to 180. If we have a right angle, the other two add up to 90. So this over here is just going to be 36.87 degrees. So there's our first two angles right there. Next, we can find angle beta. Angle beta, like theta, beta is also a heel angle. So that means it's going to be found just by using an inverse tangent of the slope of that truss. It's a 512 slope, so beta is just going to be the inverse tangent of 512. is 22.62 degrees. And to find phi up there, again, we know those three angles come together to make those triangles, two of the angles beta and the angle phi. So I'm just going to do 180 minus 2 times 22.62, giving us 134.76. So we have found all of those missing angles. Now that we have those angles, we need to find some distances. Well, looking at these, we can do some relating between the distances. First, we know that W plus Z plus another W add up to 36. In other words, 2W plus Z adds up to 36. We also know that Y plus X adds up to the 13. We have 4 variables here, though, which means we would have to have 4 equations. We only have 2 so far. The other 2 are going to come from our slopes. So we have Y and W here on that 16/12 slope. 16 over 12 is going to equal Y over W. If I do a simple cross multiply here, 12 times Y is 12Y equals 16 times W is 16W. It doesn't matter which one I solve for. I have to either change Y to W or W to Y in one of these. I'm going to just go ahead and solve for Y here. To solve for Y, I'm going to divide by 12. I get Y equals 16 over 12 is 1 1/3 W. So there is my third equation, and I'm going to use that to replace this Y here. That's going to be 1 1/3 W. Let's see what we can do to replace X there. X is off of that 5/12 slope. We know this height here is X. Down here, this is 1/2 of Z, or Z over 2. Remember, Z goes all the way across. So the run of that is half of Z, or Z over 2. So we have there 5 over 12 equals X over Z over 2, or half of Z, if you want to write it that way. So when we cross multiply here, this direction we've got 12 times X is 12X. 5 times Z over 2 is 2.5, or 2.5 Z. If I want to solve for X here, I can divide by 12. X equals 2.5 over 12 is the same as 5 over 24, Z. So X is 5/24 Z. So I can put 5/24 Z in here. So now we have this equation has been replaced by that one. We replaced the Y and the X in there with their equivalents from these other 2 equations. And now we have the 2W plus Z equals 36. Well, to make that fit, what I'm going to do is I'm going to multiply this whole equation by a negative 5/24 so that Z will cancel out. Well, negative 5/24 times 2W, that's negative 5/12 W. Negative 5/24 times Z is a negative 5/24 Z. And negative 5/24 times 36 is what? Negative 7.7 I believe. It is negative 7.5. So now I'm going to go ahead and add these 2 equations. I'm doing that addition or elimination method. So I have 1 1/3 W plus a negative 5/24, which is 11/12. W. 1 1/3 plus, 1 1/3 plus a negative 5/12 is 11/12. Here I have 5/12, I can't talk today. I have 5/24 z plus a negative 5/24 z, that just cancels out, equals 13 plus a negative 7.5 is a positive 5.5. So now I'm going to divide by 11/12 here. We're at 5.5 divided by 11/12 gives me 6. So W is 6 feet. Now that I have that, everything else pretty much falls into place. I go up here, W is 6 feet. That means this is also 6 feet. Well, 36 minus 6 is 30, minus another 6 is 24. That means Z across here is 24 feet. With that, I can find these other dimensions. Y equals 1 1/3 times W, so that'll be 1 1/3 times 6. That makes Y 8. Y equals 8 feet. Over here I have X equals 5/24 Z. Well, Z is 24, so it's 5/24 times 24, which is just 5, so X equals 5. So I have that dimension, X equals 5 there, and now I can simply find my areas. I have these two triangles are identical. Then I have this triangle, and I have this rectangle. So triangle 1 is 6 by 8. Divided by 2 because it's a triangle. And then times 2 because there are going to be 2 of them. That'll be 48 square feet. Triangle 2 up there was 24 feet wide, 24-foot base. Come on. By 5 feet of height, divided by 2, which is going to give us 60 square feet. And our rectangle was 24 feet long by 8 feet high, which is going to give us, what is that, 192 square feet, which adds up to exactly 300 square feet of area. So we found the area of the end of that gambrel roof as well. Now we could go one more step here. I did not include it in this problem, but I could have put a run on there and said, well, let's find the roof area. Let's say if this is a 60-foot roof. Well, all that's going to do is require me to come back and find the length of these slopes and take that length of each of those slopes times 60 feet. I would have the area of that roof. I'm going to trust you guys can handle that part of it on your own. Look at a roof that might be a little trickier to find. We worked with these dual slope roofs a little bit when we were dealing with generic trusses earlier in the semester. I want to make it a little more obvious that this is dual sloped. Let's say that this here is let's make it 16/12 slope. And this over here, we're going to make an 8/12 slope. We're going to put it on a span of 36 feet. I'm going to put a 2-foot overhang here and a 3-foot overhang here. I want to find alpha, beta, and theta, but I also would like to find the length of each of those top chords. Again, you can see once I have those lengths, this could translate into a roof area again, which we'll take a look at, and we'll add that to this problem. So I'm going to leave this portion of my page over here empty to find the total roof area later. So for right now, angle theta. Well, angle theta is a heel angle. So it's just going to be the inverse tangent of that slope, which is a 1612. Which I know we just did is 53.13 degrees. Theta is also a heel angle. So it's going to be the inverse tangent of that slope, which is 812, so inverse tangent of 812. Gives us that beta is 33.69 degrees. Now that we have those two angles, we can find theta up here to be 91.18 degrees just by subtracting from 180. We have all of our angles. How does that help us find those lengths A and B? Well, we have to actually ignore the overhangs for a minute and look at a problem related to this, like this. So we still know this is 36 feet here. This angle is 33.69 degrees. This angle is 53.13 degrees. And of course, the angle up here was 91 point, what was that, 18 degrees. With the overhangs cut off like this, we can find these sides here. I'll call this side D and F. I can find those by just simply doing law of sines. 36 feet over the sine of 91.18 degrees equals F over the sine of 53.13 degrees. I can cross multiply and divide to find F. (36 times sine of 53.13). Close parentheses, divided by the sine of 91.18 gives us 28.81 feet. That's F. Now, technically, I don't even need to find D here. What I need to do is I need to find the run of each of those slopes. So I need to find this run here and this run here. So I'm going to label this G and H. Actually, I don't want to use H because H is usually used for height. I'll call that G and M. To find M, I am simply looking at this right triangle here. It has a right angle here. This angle is still 33.69 degrees. And I now know that this hypotenuse is 28.81 feet. I can find the base down here, M, because that is a adjacent side. And we have the hypotenuse. It's going to be a cosine. Cosine of 33.69 degrees equals M over the 28.81 feet. So we make that a proportion by putting our trig function over 1. We do that because we're looking for a missing side, and now we'll cross, multiply, and divide. So 28.81 times the cosine of 33.69 degrees gives 23.97 feet. So this is 23.97 feet, making this over here 12.03 feet. We have our spans. Why did we need those spans? Well, because now we are going to bring back in the overhangs. This overhang was 2 feet, which means if I draw in the triangle there, including that overhang, this distance is 12.03 plus 2, or 14.03 feet. And what I'm finding here is going to be that original dimension A that I was looking for. So I have that right triangle. I'm going to redraw it down here. This is 14.03 feet with the overhang. This is my dimension A, and this angle here is the 53.13 degrees. I have the adjacent side and the hypotenuse, which is a cosine. Cosine of 53.13 degrees equals my adjacent side of 14.03 over my hypotenuse, which is A. Again, since I am looking for a missing side, I turn it into a proportion by putting it over 1 so that I can cross, multiply, and divide. So 1 times 14.03 is simply 14.03 divided by the cosine of 53.13 degrees, giving me 23.38. Wrangle it for side A. A is 23.38 feet. Now we're going to do the same thing over here for this was side B originally. I'll draw it so it is side B. We had a 3-foot overhang out here, so when this comes down and over, this is going to be a total of 23.97 plus 3 will be 26.97 feet. And this dimension all the way down is going to be the original dimension B. So let me redraw that triangle. So this is B. This is now 26.97 feet, including the overhang. And my angle is still the 33.69 degrees. To find B, again, I have the adjacent side and the hypotenuse. So I am dealing with a cosine. Cosine of 33.69 degrees equals that adjacent side of 26.97 feet over the hypotenuse of B. Once again, we're looking for a missing side, so we'll make it a proportion by putting the trig function over 1, and we'll cross, multiply, and divide. So 1 times 26.97 is just 26.97, divided by the cosine of 33.69 degrees. Gives us 32.41 feet. There's B, 32.41 feet. Come on. So that's 32.41 feet. This is 23.38 over here. Feet. Now I said I was leaving this spot blank here so that I could find the area. So what we're going to do is we're going to assume this roof is on a building that is 72 feet long with 1-foot lookouts on the gable ends. In other words, the roof is a total of 72 plus 1 plus 1, or 74 feet long. So the area of the roof is this slope times 74 feet. So 32.41 times 74 feet. Plus this slope times 74 feet. 23.38 times 74. Now I'm going to take a shortcut, and I'm going to add the 32.41 to the 23.38 first. So all the way over the roof would be 55.79 times the 74 gives me 4128.46. So the total roof area of this is 4,128.46 square feet. Now, yes, I realize there's a lot of steps there, But this one really isn't that bad. As long as once you find the angles, you realize that you have to clip off those overhangs so that you can use lost signs to find the top chord links without the overhangs. And really, the only reason you need that is so you can get your run of each of those slopes. And once you have that broken down so that you have those right triangles on each side, in other words, you found the location of the peak, then it's fairly easy. It's just right triangle trig from there. Next on our list for the day is a hip roof. This is going to be hard to draw. Apologize for my artistic struggles. I'm going to try to make this look three-dimensional. Not terrible. So here's a hip roof. And what we're going to do with this hip roof, we're going to start off with a 32-foot span here. A run of, let's just make it 60 feet. Keep it nice and even. We are going to have a 612 slope on this side and an 812 slope on the hip end. So main roof is 612, hip ends are 812 slopes. The things I want to find. Number one, I want to find my ridge length. I'm going to call that X. I want to find some angles. I'm going to call this angle alpha. This angle here, angle beta. This angle here, gamma. And this angle here, I'll call angle phi. I want to find those four angles. And we'll find the area of the roof while we're at it, just for fun. Hopefully everybody's had time to draw that out. So I want to start off with, just like we always would on any of these hip roofs, the common rafter. So the common rafter's on the main roof here, and I'm actually going to take it right here where the ridge stops and it slopes into the hip. The reason I'm doing that will help me with some of those angles later. But it's just this common rafter, the span of 32 feet, slope of 612. We need to find the height. That height has a run of 16 feet. So it's 6 over 12 equals h over 16, giving us h is 8 feet high. That 8 feet will be important when we get to the hip end in a little bit. For right now, however, we want to do the length of the common rafter here, which is going to be very important. That's just going to be the square root of 16 squared plus 8 squared. We have 17.889 feet. So this length here is 17.889 feet. That's going to be an important dimension in just a minute. Next, we want to look at the hip end. And more specifically, we're looking at the main jack. The longest jack there, which is right here. What we know about that jack, we know two things. We know it has an 812 slope, and we know the height here is 8 feet from what we found up here on the common rafter. The hip rafter and the common rafter have to have the same height. They all meet at the same ridge. So we can use that to find this length here, 8 over 12, because that's our setback. We'll call that S, equals 8 over S. Well, we cross multiply and divide. We simply get that S there is 12 feet. Just like with the common rafter, we want to find the length of the top chord there. It's going to be the square root of 12 squared plus 8 squared. Here is 14.422. Square root of 12 squared plus 8 squared. Now we are ready to start finding. Well, first of all, we can find x. We've got a setback here of 12 feet. That would be a setback over here of also 12 feet. 60 minus 12 minus another 12 is 36 feet. It always amazes people how short that ridge becomes in a hip roof. Even though a 60-foot run seems like a pretty long run, but that ridge only being 36 feet is considerably shorter. Let's get back to finding. We actually have everything we would need to find areas right now, but let's go ahead and find our angles first. Look at the hip end. We have that triangle laid out there. Now this triangle, that's this triangle here, which is actually laying on the slope of that hip. Come on, erase, darn you. And we know that this width here is 32 feet. And we found this to be 14.422 feet. So what we're going to look at is just half of that. This triangle here, where this is now going to be 16 feet. This angle is going to be the inverse tangent of the 14.422 divided by 16. Giving us 42.03 degrees. Now there's two different ways we could go about finding this angle up here. We could find this one as the complement of the 42.03 and then double it. Or we could take the whole, go back to the whole bigger triangle again and say, hey, we've got 42.03, 42.03. We subtract both of those from 180. And we'll get this angle up here is 95.94 degrees. So there's two of our angles that we're looking for. Go now on the main roof side. We have there's a trapezoid where this is 60 feet and this is 36 feet. To cut this off, we know that this setback is 12 feet and that common rafter 17.889 feet. So right away I can find this angle right here as the inverse tangent. So 17.889 divided by 12. Giving me, inverse tangent, my second intake. Give me 56.15 degrees. Now that I have that, I am going to actually find this angle here, which is its complement. 90 minus 56.15 gives me 33.85 degrees. And the reason I want that is because this is a 90-degree angle. So I would add those two together to get that this overall angle here is 123.85 degrees. I have all of our angles. Now let's find our areas. Well, I'm going to use these same shapes for areas. This area here is simply going to be 32 feet on bottom times 14.422 feet. Altitude divided by 2 because it's a triangle, but we're going to multiply by 2 because there's one on the other end. So 32 times 14.422 divided by 2 and times 2 really cancels each other out. We get 461.504. And that is square feet. That symbol, by the way, that's just a square with the foot symbol through it. That's a shortcut for writing square feet. This one here is just a trapezoid. We have 60 plus 36 divided by 2. That's the average of the bases times that height of 17.889, and then times 2 because there's 2 of them. You do the 60 plus 36, make sure you hit equals before you divide by 2, so that works out correctly. So we've got 48 times 17.889 times 2 is 1717.344. Again, square feet. So our result here, $2,178.848, basically 2,179 square feet of roof area. Now, the other thing we would want to do if we were actually doing an estimate on this roof is we would want to find total length, hip, and ridge. So the total length of ridge is just 36 feet. Total length of the hip is this length right here. That length is just going to be the square root of 16 squared. That's the run. Plus 14.422 squared. It's 21.541 feet. And that's going to be times 4 because there's 4 of them. That's a total of 86.16 feet of hip. So we add that together, 122.16 feet of hip and ridge, just because you use a cap shingle for those hips and ridges. A lot of crap already in just 40 minutes. I apologize. I feel like I'm talking a little bit fast today. That is the material that you're going to know for the homework. There will be a quiz on Monday on this stuff that we have done the last few days. Before I assign you the homework here, I want to review a concept from last semester. And that concept is an arc. Remember, if we had an arch above a window, let's say it was a 48-inch window, and let's say we wanted to have an 8-inch high arch above it. To find the radius of that arch. In other words, if this were a full circle, yes, I know I made it kind of squished, what would the radius of that circle be that arch is based off of? Well, what we do is we extend this 8 down here like this. I'm going to call this length x. That splits the 48 inches in half, so it's going to be 24 inches and 24 inches. The relationship, if you recall, is the product of the pieces of each chord. They multiply to be the same. So this chord is 24 and 24. So 24 times 24 has to equal, this one is 8 and x. So 8 times x. So we solve that by doing 24 times 24 divided by 8. Gives us 72 equals x. So x here is 72 inches. The diameter of that circle then is this distance all the way across is just our 8-inch arch plus our 72 inches for x gives us an 80-inch diameter. So our radius is 80 divided by 2, or 40 inches. That's going to be an important skill to remember as we go into next week. So with that, we have about 30 minutes left. I will give you that time to get started. There is an attached worksheet out there, attached for today, April 15th. Work on that. I will be online here for a while to help you out if you have any questions. Otherwise, you all have a great weekend, and we will see you on Monday.